Lecture 5 of KV4000 programming, and this week we'll be looking at repetition. But before we get into the main body of the lecture, now that we're beginning to get into coding, it might be useful to have a look at the big picture of what we're trying to achieve with this module. And here we can see a movie of a simple breakout game, which I'm sure most of you are familiar with. So the aim is to destroy the bricks by hitting them with the ball, which you control by moving the bat. And hopefully you already recognize certain features, such as the bouncing ball, because this essentially is what we're building towards over the course of the next few lectures. Of course, this isn't going to win any gameplay awards, but hopefully you can see how it's a relatively sophisticated piece of software that we can build ourselves. By gradually building up week on week our techniques and our skills and knowledge, we can move from moving a ball across the screen and bouncing it off the edge to a fully featured game. And none of this is beyond any of you if you take the time to learn the techniques that we'll teach you. And once we've built our breakout clone, we'll spend a further couple of weeks developing other game type software. So hopefully you'll find it fun as well as informative, and you'll sort of get to see under the bonnet of the sorts of casual games that you might play, for example, on your phone. So over the course of the last few weeks, we've seen how we can draw things across the screen and keep track of how we do that using variables. So for example, we use variables to keep track of the X and Y positions of a ball, which we then added 1 to or subtracted 1 from each time around the draw loop in order to move the ball. So we're already familiar with this idea of using variables to keep track of doing things over time. And this is very important because computers are very good at doing things over and over again. So like the Terminator in the film, they don't feel pity or remorse or fear, and they will absolutely not stop ever, well, until you quit the program or there's a power cut. So understanding repetition is a fundamental skill of being a programmer, and part of that is recognizing situations in which repetition occurs, how to handle those situations, and deciding which control structures to use in particular scenarios. So we use the term iterate or iteration to talk about repetition, as we can use the verb to talk about the action of iterating over, say, a list of students, or we can use the noun to talk in terms of stopping after the 6th iteration. Okay, so like other programming languages, processing gives us a number of control structures that we can use to implement iteration, each one being suited to a specific scenario. So it's probably easiest if we illustrate these with some examples. So before we do this, we should point out the fact that unlike most other programming languages, processing already contains a sort of implicit type of iteration due to the fact that the draw function is called repeatedly. So you could think of this as iteration for free because you don't actually have to do anything explicitly to use it. It's implicit. But we saw how it could be sort of controlled or harnessed by, for example, keeping track of the number of iterations using a counter or having a toggle switch that we can control. That means that we only do something inside the loop if the switch is on, and so on. So draw gives us a higher level form of repetition, but we may want to implement more specific repetition inside draw. And let's see how we do that. So I guess the first stage of iteration, in terms of understanding it, is to understand why we might want to use it. So with that in mind, take a moment to look at this code and have a think about what it does. So pause the movie and try to work out what you'll see when you run this code. Well, obviously, the answer is a bunch of lines, but notice how they're drawn, and notice that there's a one-to-one mapping between the actual lines and the lines of code. So the first call to line draws this line from 2020 to 2180, and so on. What happens if we wanted to change the appearance of the lines? What happens if we wanted to change the spacing, for example? So if we insist on this sort of one-to-one mapping between line of code and almost manually draw the lines individually, then the coordinates are hard-coded into the program. And then if we want to change anything, we have to change every single line of code. And if we have to do this for 100 or 1,000 lines, then hopefully you'll see how this would quickly become not just inefficient, but mind-numbingly tedious and also prone to errors and mistakes. So obviously there's a better way of doing it. And it just requires the ability to spot and use patterns of repetition. So based on what we know that the code produces, this output here, what patterns can we see in the code? Okay, what regularities are there? So pause the movie and have a think. Well, obviously the patterns in the code match the patterns we see in the output. So remember, the line function takes in 4 arguments, 4 integers. The first 2 specify the coordinates of the start point of the line, and the second 2 specify the coordinates of the end point. And the end points of each line are all the same in terms of their y coordinates. So they always start at 20. So this is the y for the start point, and this is the y for the end point. And you can see how it's always 20 and always 180, because this makes perfect sense. All of the y coordinates of every single line starts at 20 and ends at 180. Okay, so that's a pattern that we've identified straight away. So the only thing that's changing is the x coordinate of each line. Okay, and there's a regular pattern there as well, because the lines are spaced out at an interval of 10 pixels, so they all start at 20 and end at 140. Okay, so they all start in terms of their y at 20 and 180, but they start at 20 and end at x equals 140. So just to summarise, we have lines that start at x20 and go up to x140, and in steps of 10, and each line goes from x20 to that x180. So how do we formally describe this in pseudocode? So we might say, for example, if we want to draw these lines, for values of some counter x which runs from 20 to 140 in steps of 10, draw a line from x20 to x180. Now this perfectly captures the description of what we want to achieve, and importantly, as we'll see later, it's much shorter and more general, and it means that if we want to make any changes to the pattern, we can make them in a much more straightforward manner. And importantly, this allows us to say things like for each. And we want to do this a lot. Okay, for each student, tell me their mark. For each ball in play in the game, move the ball. For each item on a supermarket till conveyor belt, add its price to the total bill, and so on. So we can use variables to keep track of the values, the ranges, the indexes, and so on that are in play.